Example 4 asks us to consider f of x is equal to e to the x times sine of x. We can calculate f of 0 and also the derivative of f of 0 and use that to approximate f of 0.1, f of negative 0.1, and f of 0.03. We'll be using differentials to do so. We see f of x is equal to e to the x power multiplied times sine of x. I'm going to calculate the derivative before I start plugging in values into the function. The derivative would require us to utilize the product rule. If you remember, the product rule says we take the derivative of the first part, derivative of e to the x is e to the x, multiplied times the normal second part, plus the normal first part, which again is e to the x, times the derivative of the second part. The derivative of sine of x is cosine of x. So here is our function, and here is our function's derivatives. If we plug in 0 into each thing, f of 0 becomes e to the 0 multiplied times sine of 0. You can plug that in to your calculator, but it's going to come down to the fact that sine of 0 is 0. Therefore, f of 0 is 0. The derivative of f at 0 is going to be e to the 0 sine 0 plus e to the 0 times cosine of 0. The derivative is actually 1 when you multiply that out. So that is the function's value and the function's derivative value. Now we can approximate the function values which we are given. Let's begin by approximating f of 0.1. We're going to do so by taking f of 0 and adding f prime of 0 multiplied times dx, the differential. I should have once again written that this is an approximation, so I'll use this symbol here. F of 0 we know is 0, f prime of 0 is 1, and in this case dx is 0.1. So f of 0.1 is approximately 0.1. How about f of negative 0.1? F of negative 0.1 is approximately f of 0 plus f prime of 0 dx. Our differential there is negative 0.1 because from 0 down to negative 0.1 is a change of negative 0.1 with respect to x. So f of 0 is 0, f prime is 1, and negative 0.1 is our differential. So the approximate value of f of negative 0.1 is negative 0.1 or negative 0.1. The last function value we're trying to approximate is f of 0.03. Once again, I take f of 0 plus f prime of 0 times the differential. In this case, it's going to be 0 plus 1 multiplied times 0.03 or 0.03. And we get 0.03 as our answer. You can plug all three values into your calculator and see how close of an approximation you get. Like e to the 0.03 multiplied times sine of 0.03 is, again, should be very close to 0.03. In fact, it is 0.030909, rounding to a few decimal places. So we see that this technique works no matter what types of derivatives we're taking. In this case, I had to use a product rule to obtain the derivative. But as you can see, it's pretty easy to plug in 0 into both this function and the derivative. If we were doing this by hand and we didn't have use of our calculator, it's much easier to approximate using differentials than to try to figure out e of 0.03 or e of 0.1. So you can see the advantage, especially if you don't have use of a calculator. The advantage is this technique is a much easier process if you don't have use of a calculator.